Good evening. Tonight in our video lecture we're going to look at Coulomb's law and how it applies to multiple charges. So instead of just looking at two charges, a pair of charges, we're going to look at it as it pertains to three or more charges or two or more charges and moving up from there. I'm going to skip kind of the easy idea of it in a straight line, and we're going to move to a more complicated idea of Coulomb's law applied in two dimensions. And particularly what we're going to look at, so here's Coulomb's law, and we remember that we have the electric constant K, that's 8.99 times 10 to the ninth, and that's in newtons meter squared over Coulomb squared. The other idea that we're going to look at, a lot of the times what we will be dealing with is microcoulombs. So 1 microcoulomb, because a coulomb of charge is an incredible amount of charges. It applies a huge amount of force. And a whole coulomb of charge, a force could be like exerted over like a kilometer or something like that. But a small amount of charge, a microcoulomb, is much more, I wouldn't say, I guess, common, but it's a much more applicable amount of force to deal with in this situation. And it's probably, we'll actually look at how much charge is being put on a balloon or something like that at one time. But we'll go through that during class. So 1 microcoulomb is equal to 1 times 10 to the negative 6 coulombs. So those are that's how we're going to set it up, and we're going to use our basic formula right here. So what I've done is drawn kind of a simple setup. Here I have charge 1, charge 2, and over here I have charge 3. Now for this, let's just make it a little bit easier here and say that charge 1 is a positive charge of strength 1 microcoulomb. So Q1 is equal to 1 microcoulomb. Let's also make it a little bit easier here, and say charge 2 is also, this charge right here, also going to be 1 microcoulomb. But in this case, let's make it negative. Q2. And finally, we're going to have charge 3 over there. And I'm going to say that it's a little farther away. Let's make it a little bit stronger. Let's have a little fun. Who knows? We're going to say charge 3 is equal to negative 2 microcoulombs. Now, before we begin this, we're going to kind of look at what are the effects of each individual charge on each other. So if I look at this, let me grab another color here. The force of charge 2 on charge 1 by Newton's third law is going to be equal to the force of charge 1 on charge 2. And so if we look at here, and we're going to look at charge 1, what effect does it feel from charge 2? It's going to feel an attractive force, they're opposite, and so that means there's going to be some force directed in this direction. Now, what about charge 1 and charge 3? Charge 1 and charge 3 are opposite in charge, so they're going to feel, it's going to feel an attractive force between charge 1 and charge 3, so there's going to be some force in this direction. Even though we're not really concerned with it, charges 2 and 3, since they're the same charge, they have the same, they're both negative, they will feel a repulsive force away from each other, so somewhere in this direction or that direction. Now, so we have each one of these individual forces here, and what we're going to use is we're going to use Coulomb's law here to go and figure out the magnitude of each force. Once we figure out the magnitude of each force, we're going to go through and we're going to calculate out what the actual net force is on charge 1. In order to do that, we need to know the distance. So let's just kind of make this easy. We'll say that this distance here between 1 and 2 and I'm just going to subscript this 1, 2, is equal to 1 centimeter, which is 0.01 meters. And to make it easier, we'll say this is twice the distance here. So R, the distance between 1 and 3, 0.02 meters. So we have a distance here of 0.02 meters or 2 centimeters. We have a distance here of 0.01 meters or 1 centimeter. Now, in order to go and solve out for the magnitude of these forces, we just need to set it up for each individual force. This force here is the force of charge 2 on 1, and that's how I'm going to write my subscript. And this force here is the force of charge 3 on charge 1. So that's why I'm going to just set that up like that. Now, in calculating amount, you're going to do this the same way as you normally would with just any two sets of charges. So let me here, I'm going to erase all this. And give me a second here to write this all up, and I'll come back in a second. Alright, so what I've written up here is how I'd like you to set it up on your sheet there, showing your work and doing this algebraically. Remember, I want to make sure you put it all out there with all the variables before you plug in the numbers. So I have the force on charge 1 by charge 2 is given by the electric constant, charge 1, charge 2, and the distance or the radius between the two of them squared. So here we have that distance there, which is just happens to be 0.1 meter or 1 centimeter. So if I set this all up, I get in there, I should get something close or right around, depending on my rounding here. If I set this at just round that to 9, I should get something around 90 newtons. The same idea here for the force on charge 1 by charge 3. I have the electric constant, charge 1, and now I substitute in charge 3, and then I have the distance between those two charges. Now, once I'm able to calculate that force, and in the end I would like you to calculate that force and put it in online, and please be specific in your actual value that you go and put in onto the answer key. I now have force of 3 on 1 and the force of charge 2 on 1, and I have some net force in this direction. From this point, you can use trigonometry and be able to solve for the value and the magnitude of this net force and the angle that it's given at. I'd like you to use a polar coordinate to solve for the angle. So if this is 0, 90, 180, 270, this is going to be somewhere greater than 270 degrees. So that's what I'd like you to do tonight, please, is actually solve for the net force on charge 1, given that the charge 1 is equal to 1 microcoulomb. Charge 2, a distance of 0.01 meters away, directly downward, or at an angle of 270 degrees, is negative 1 microcoulomb. And charge 3, located 0.02 meters away, 2 centimeters away, from charge 1 at a 0 degree vector, is a negative 2 microcoulombs. So go ahead, figure out the net force along with the angle and the value for the secondary force of charge 3 on charge 1. Thank you very much. Make sure to put your answers in online. Show your work if you have any questions and come to class with that. Have a good evening. Thank you.